Let's get started on part 3 of chapter 10. Let's discuss public and private IPv4 addressing. As you know, TCP IPv4 has a 32-bit address space. The IP address is made up of 32 bits. Each octet is represented by 8 bits. Add them all together, you got 32 bits. So the limitations of IPv4, since you have 32 bits, the maximum number of IP addresses is 2 to the 32nd, which is 4 billion. The maximum number of IP addresses that can be derived from 32 bits is 4 billion. Well, the population of the planet is 6 billion, and many people have multiple IP addresses. So the statement of the problem is we are running out of IP addresses. The statement of the problem is that we are running out of IP addresses. So the solution is either to use IPv6 or to use private IP addressing and NAT. So now let's discuss public and private IP addressing. Now I think you already know what a public IP address is. It's an IP address which is globally unique. It used to be all they had was public IP addresses. And globally unique means no two computers on the face of the earth should have the same public IP address. And that's nothing new. But what is new is this business of private IP addresses. Now, private IP addresses are typically used within an organization, and many organizations can use the same internal IP addresses. These IP addresses are not globally unique, and they don't work over the internet. So the question is, how can computers using private IP addresses get on the internet? And this takes us to NAT, the Network Address Translation Protocol. NAT is software that runs on the router that allows many computers using private IP addresses to share one public IP address. Here's the example: CCBC and Howard Community College. Within CCBC and within Howard Community College, we use the same IP addresses. But wait a minute, I thought you can't have any two computers with the same IP addresses. You can in private IP addressing. In CCBC, we have computers in range 10.0.0.0, and the same IP addresses are used at Howard Community College. These are private IP addresses. But to connect to the internet, you must use a public IP address, which is a globally unique IP address. So the way it works is NAT, a network address translation software, allows these many computers to share this one private IP address. Same thing at Howard Community College. These many computers are allowed to share this one single public IP address. The public IP address is the IP address that connects you to the internet, and it must be globally unique. Private IP addresses do not have to be globally unique. So NAT allows many computers using private IP addresses to share one single public IP address. So here's how things have changed at CCBC. At the Catonsville campus, formerly, we needed 3,000 public IP addresses so each computer could access the internet. But now our internal computers use private IP addresses, and they all share one public IP address. So now, instead of needing 3,000 IP addresses at CCBC Catonsville, we only need one. Same thing at Howard Community College. This is an example of a large institution with an address of a Class A network, 10.0.0.0. Now you can do the same thing in a SOHO, small office, home office. This would be an example of a Class C network. Each computer uses IP address range 192.168.1 internally, and all of these computers use private IP addresses, and they share the one single public IP address, and this is what most of us have at our wireless networks at home. The IP addresses used by my computers in my house are the same as the IP addresses used in your computers in your house. But what's different is the IP address that connects us to the internet, the IP address which is assigned to the cable modem. The public IP address must be globally unique. All these computers are sharing this one public IP address. Here's an example of a large organization. Here's an example of a small organization. Private IP addresses are used internally, and a large organization would use a Class A private IP address range, such as 10.0.0.0 with a subnet mask of /8, and a Class C network, and a small network would use an IP address, a private IP address of 192.168.1.0 with a subnet mask of /24. And all of these computers using private IP addresses share a single public IP address, and it is the network address translation on the router that allows many computers using private IP addresses to share one public IP address. This is one way to address the problem that we're running out of IP addresses. DHCP, the Dynamic Host Configuration Protocol, is covered both in this chapter and is covered in greater detail in Chapter 11. So let's just do the overview of DHCP and cover it in greater detail later. Manual IPv4 address configuration means you walk up to the first computer and you type in the IP address. You go to the second computer and you type in the IP address. You go to the third computer and you type in the IP address. CCBC has 5,000 computers, and to walk around to each individual computer and type in the IP address can be awfully time-consuming and labor-intensive, and there is a higher probability of typographical errors which can lead to duplicate IP addresses. So, we use the Dynamic Host Configuration Protocol. The Dynamic Host Configuration Protocol is where we have a DHCP server that issues the IP addresses to the clients. You don't have to walk around to the clients to issue the IP addresses. A DHCP server has a group of IP addresses, which they call a scope, and we do not walk around to the first computer and give it an IP address, and go to the second computer and go to the third computer. The DHCP server pushes IP addresses down to all of their computers. It has a group of IP addresses, and it pushes the first IP address to the first computer and the second IP address to the second computer, and it saves us the trouble of walking around to each individual computer. To configure a DHCP client, in other words, to configure a workstation to grab its IP address from the DHCP server, here's what we do. We go into Control Panel in the Network and the Internet and in the Network Connections, and then under TCP/IP version 4 Properties, we click on Properties, and instead of typing in an IP address, we click on the radio button that says Obtain IP Address Automatically. In fact, that's the default when you install Windows 7. When you install any copy of Windows. If you click on the radio button that says Obtain IP Address Automatically, then here's what happens. When the computer powers up, it sends a request to the DHCP server, and the DHCP server pushes down the first available IP address. Saves you the trouble of walking around to each individual computer. With the DHCP, the Dynamic Host Configuration Protocol issues IP addresses to clients. Now, let's discuss automatic private IP addressing. What if the DHCP server goes down. Well then, how can the workstations possibly get an IP address? If the DHCP server goes down, the workstation generates a temporary IP address of the format 169.254.x.y, whereby x and y are randomly generated numbers, and the workstation uses that IP address to communicate with other computers. When it has an IP address which is automatically generated, it cannot connect to the internet. It can be used to connect to other computers in the same subnet, but it's not going to go over the internet. So if the DHCP server fails, the workstation generates a temporary IP address, and every 5 minutes it hits the DHCP server again and requests an IP address. If you go to a workstation and you type ipconfig and press the enter key, and if you see an IP address of 169.254 followed by something.something, then that means that the workstation is a DHCP client, but it was unable to contact the DHCP server, so it generated its own temporary IP address of the format 169.254.x.y. Automatic private IP addressing. So there are 3 methods by which a computer can receive an IP address. Static configuration, which is also called manual configuration, where you walk up to every single computer and you type in the IP address. Or you use dynamic host configuration protocol, which pushes the IP addresses down to all of the individual workstations. And if DHCP doesn't work, then automatic private IP addressing is where the workstation generates a temporary IP address and then tries to hit the DHCP server every 5 minutes. And of course, we will cover DHCP in greater detail in Chapter 11. And this concludes Part 3 of Chapter 10.